So now we're going to complete the square when the number in front of x squared is not 1. So in this case, we have a trinomial that's 2x squared plus 8x minus 26 equals 0. You could take a GCF out as well, but in a lot of cases, what we're going to do is we're just going to divide the number in front of the x squared by everything. And that's how we deal with a problem with completing the square where the a is greater than 1. So if you notice in this problem, I literally just divide each term by 2. And I'm left with x squared plus 4x minus 13. And then it's completing the square as we've done before. We add the 13 to both sides. So now I'm at x squared plus 4x equals 13. I take half the middle term. 4 divided by 2 is 2, and 2 squared. And I add 4 to both sides. When I factor x squared plus 4x plus 4, I get x plus 2 squared. That's x plus 2 times x plus 2, so the x plus 2 squared equals the 13 plus 4, which is 17. And then we square both sides to get rid of the square. And we're left with x plus 2 equals plus or minus the square root of 17, and then we finish with subtracting 2 to both sides. If I look at this second problem right here, I have a 3 in front of my x squared, so instead of dividing by 2, I just divide every term by 3. And now I'm left with x squared plus 4x minus 1 equals 0. And I follow the same process. I add 1 to both sides. I take the middle term here, take half of it, which is a positive 2, and square it, which makes it 4. So I add 4 to this side, and I add 4 to that side. This factors to x plus 2 squared, which would equal 5. We square root both sides, and then I just subtract 2 on both sides, and my answer is negative 2 plus or minus root 5. So that's how I do completing the square when there is a number in front of the x squared. I just have to get rid of that number by dividing every term by the number in front of x squared. It'll guarantee you that 1 in front of x squared, and then you complete the square as we've learned previously.